Here we have the notes for Algebra 2, Section 5.1, and they have to deal with properties of exponents. And before we start actually looking into the properties of exponents, we want to take just a moment to recall what exponents are. So for instance, if I had x to the fourth power, the 4, or the power, is the exponent. And what that exponent does is tells me that I have 4 x's, 1, 2, 3, 4, being multiplied together. So I have this repeated multiplication of these 4 x's. That's x to the 4th. Now everything that we learn about exponents will come back to the idea that x to some power is that many x's being multiplied together. Now, as long as we've got that in our minds, let's actually look at some of the properties we're going to be dealing with. Now, there are 6 of them in all that we're going to be concerned with. The first one is called the product of powers. Powers, of course, are exponents. A product is the result of multiplication. So what we're talking about here is the multiplication of exponents. So when we multiply terms that have exponents, we use the product of powers. Now I have a to the m times a to the n. Notice that both of these have a in them as the big number. The big number is usually referred to as the base. So a in this case is the base, with m and n being exponents. If I have 2 numbers that I'm multiplying together and they have the same base, I'm going to add the exponents. So a to the m power times a to the nth power becomes a to the m plus n. A to the m plus n. So multiplying the terms resulted in adding the exponents. And if we see an example here, it would look like this. If I had x squared times x to the 3rd, that would be x to the 2 plus 3, which equals x to the 5th. Now, of course, I don't have to write this step out every single time. Once I've got the idea, I can just jump right to it. Now, in the next example here, the power of a power. Now, power, of course, is exponent. And we're taking the exponent of an exponent. That means we're going to raise something that already has an exponent to another power. So an exponent of an exponent. When we do that, I have, in this case, a to the m to the nth power becomes a to the m times n. So I multiply m and n. So raising to an exponent resulted in multiplying the exponents. An example, for instance, might be if I had x squared and I raised x squared to the 3rd power. Now keep in mind that would be x squared times x squared times x squared, because it would be 3 x squares multiplied together. And of course, using the product of powers, I could say this is 2 plus 2 plus 2, which is x to the 6th. But the easier way would be to say that this is x to the 2 times 3. These are both identical statements. X squared plus x squared plus x squared, or times x squared times x squared times x squared, is the same thing as x to the 2 times 3. So that's the way we're going to think of it. We are going to think of this as x to the 2 times 3, which is x to the 6th. Now the next product, the power of a product, is when we have an exponent power exponent of multiplication, because product, remember, is multiplication. So if I have the exponent of multiplication, or if I had a times b to the mth power, what that would look like would be a to the m times b to the m. So both of my individual terms got raised to the mth power. An example of that, we'll have a look here, would be, for instance, if I had x, y, two terms being multiplied together, raised to the second power. Well, it would be x raised to the second power times y raised to the second power. That will be the result. Moving on. Here I have a negative exponent. So if I have an exponent that's a negative number, this one's kind of an oddball here. If I had, for instance, a to the negative mth, here's how this would look. I would take this. Now, the first thing we need to do is realize that a to the negative mth is always over 1. Every single number that we deal with is always itself over 1. Now, what we want to do here is this negative exponent takes the entire term, a to the negative mth, the entire term will flip upside down, right? You'll find that you'll take the reciprocal. Remember reciprocal. The reciprocal of 2 is 1 over 2. The reciprocal of 1 over 3 is 3 over 1, which is just 3. So I have a to the negative m over 1 becomes 1 over a to the m. Notice that the negative sign went away when I took the reciprocal. And that's really all the negative sign tells you to do with exponents, is take the reciprocal. An example of this would be if we had, say, x to the negative second. Well, that would be 1 over x to the second, and that's it. We don't have to go any further with it. The quotient of powers, now quotient, you should remember, is dividing. So the quotient is divide. So if we divide terms with exponents, such as a to the m over a to the n, the result of that would be a to the m minus n. We subtract the bottom from the top, so m minus n. An example here, we would have, for instance, x squared over x to the third would be x to the 2 minus 3. 2 minus 3 is negative 1, so it would be x to the negative first. And we could either write our answer as x to the negative first, or, as you may have guessed, 1 over x, because that negative first tells us to take the inverse, the reciprocal. All right, here we are. Power of a quotient. Of course, power is exponent, and quotient is divide. So if we're taking the power of a quotient, that means we're giving something that's being divided a power. In this case, I have a over b to the mth power. And what all that does is give me a to the m over b to the m. That's it. So an example might be if I had x over y to the third, that would be equal to x to the third over y to the third. Now those are our main properties. I know that there's a lot of them, so what I would suggest is you stop the video at this point, look over those properties, make sure that you kind of get an idea of what each of them is. Now you'll be able, of course, to look back through your notes as we go through assignments, but you do want to be able to identify which of the properties is being used at any one time, because when we start going through our examples in a minute, that's what's going to happen. So if you'd like to take a moment to pause the video and look back over your notes, or rewind to look at what I just said, feel free to do that now before we move on to example 1. Alright, we're moving on to example 1. And in example 1, we're just dealing with regular numbers, and we want to evaluate. Now, of course, if we were so inclined, we could just type what we've got here directly into the calculator, and it would give us answers. But we want to look at this using the properties of exponents to get some practice with them. Now, I have 6 squared to the 3rd power, which is, as you would go back, that is our power of a power property. It was the second property in our list. And the power of a power property says that if I have a term being raised to an exponent, then I multiply the exponents. So I would get 6 to the 2 times 3. 6 to the 2 times 3 is 6 to the 6th power. Now I can type this into a calculator, any calculator in the world, and I can get the correct answer. And the correct answer happens to be 46,656. 6 to the 6th is 46,656. So we use the power of a power property to get that answer. The next problem here, 4 to the 5th over 4 to the 3rd. Now we go back through our list, and we can see that this is the quotient of powers property. It is the 5th one in our list. Now the quotient of powers property says that if I have a to the m over a to the n, I would get a to the m minus n. So that's what I'm going to do. I'm going to have 4 to the 5 minus 3. 5 minus 3 is 2, so I have 4 to the 2nd. 4 squared, of course, is 16. So that's my answer. My last problem here, 7 to the negative 3rd. This is the negative exponent property. It's the 4th one in the list. And it says that if I have a term to a negative power, I take the reciprocal. So 7 to the negative 3rd becomes 1 over 7 to the 3rd. And 7 to the 3rd is 343. So 1 over 7 to the 3rd is 1 over 343. Now, if you had done this in the calculator, you would have gotten a decimal, at which point you would have had to convert it back into a fraction because your answer would need to be in fraction form. All right, let's look at another example here. This one's a little bit more complicated, moving a little bit forward. We have example 2, which is asking us to simplify this expression. And we're going to go through this. There are several steps involved. We're going to break each one of them down with which property we would use to get this answer. Now, on the bottom, I have x to the 15th and y to the 8th. On the top, I have x to the 5th, y to squared, all raised to the 3rd power. Well, since I'm raising this product to a power, I'm going to use the power of a product property. That's the 3rd one in our list. And it says that I would raise each individual term to the 3rd power. So I'm going to rewrite this as x to the 5th to the 3rd power times y squared to the 3rd power. On the bottom, nothing's happened yet. X to the 15th, y to the 8th is just going to stay that way. Now my next step, I'm going to use the power of a power property because I have x to the 5th to the 3rd and I have y squared to the 3rd. So I have two powers being raised to another power. Now the Power of a power, the second property in our list, says that we multiply the exponents. So I would have x to the 5 times 3 times y to the 2 times 3. Again, this is over x 15th times y to the 8th. Now, I'm just going to go ahead and do this multiplication here. That's all I'm going to do at this step, just so I can sort of be where I want to be to begin with. So let's just do some multiplication here. 5 times 3 is 15. So I have x to the 15th times y to the 2 times 3 is 6 over x to the 15th times y to the 8th. Now, if you're seeing the same thing I'm seeing, and you should be, you would probably know that we're looking at the quotient of powers property. Quotient of powers property is the 5th one in our list. And so that's the next one we're going to use. The quotient of powers property says that if we have division going on, we subtract the exponents. So I would have x to the 15 minus 15 times y to the 6 minus 8. And we do that subtraction. We end up with x to the 0. This is simplifying. This is all we're doing here. X to the 0 times y to the negative 2. Now at this point we're going to see a property that we hadn't dealt with before. The property that we're looking at here deals with this x to the 0th power. Now x to the 0th power is a special case because we have the 0th power. Anytime, and this is a flat rule, anytime you have an exponent of 0, that means that this entire thing, x to the 0, is just 1. So x to the 0 becomes 1 times y to the negative 2nd. And of course, 1 times anything is just itself. Let's see, so this is the end of our problem. You can see now I've got 1 times y squared, which the 1 doesn't matter. But I do have y to the negative 2nd. And y to the negative 2nd, using the negative exponents property, gives us 1 over y to the 2nd. And that is our final answer. You'll notice we did have, like I said, several steps. The trick here is just to do each step individually as you go. Don't try and do too many things at once. Don't try and skip steps. That's probably the number one mistake people make, wanting to skip steps. Don't do that. If you skip steps, you're going to run into problems. Okay. The last example we will do together in class. So you need to have up to through example 2 completed before you come into class. And we can deal with example 3 and your assignment in class.